Here is the mini project presentations on production system of Keropok Lekor manufacturing by the subject EPF 4808 processing machinery system and automations under Dr. Muhammad Salahuddin bin Muhammad Basri. And hello, my name is Olja Chen with matrix number 194529. Here are some introductions to Keropok Lekor. Flow diagram of Keropok Lekor is first unloaded the raw fish from truck. The unloaded fish are cut using sharp knife and remove the head, tail, guts, and bones. The fish are then cleaned manually and grinded using grinder into a paste form and mixed with several types of ingredients by hand, which took around 30 to 40 minutes, and into the dough form. The dough are then hand rolled and shaped into crepe shape. The next step will be the cooking process. So the shaped fish dough are boiled with water at 100 degrees Celsius. After that, the cooked Keropok Lekor are cooled by using stand fans, and the cooled Keropok Lekor are coated with oil by hands to maintain its moisture content. Now the Keropok Lekor are done and packed manually. The packed Keropok Lekor are stored and distributed to retail stores. Basically, this process flow diagram is obtained from one of the traditional Keropok Lekor producers in Terengganu, which named Pokulong Keropok Lekor Small Enterprise. This traditional way of processing has brought some issues such as high labor required, as it is mainly 80% are done manually. So this means more workers are required, such as the transferring of the food materials from one station to next stations for further processing. Besides, the production rate of Keropok Lekor is low, which this low output per hour of labor input sometimes is unable to provide sufficient productions to meet the demand from customers. Furthermore, the conformity to quality specifications is low as well. For example, the products produced are inconsistently in shape as it is done by hand milling. This is the existing floor plan of the Keropok Lekor company. The main issue here is the hygienic problem during the production system, where the separation among the workplaces are not clear. Besides, all the dry materials such as powder ingredients, flour, packaging materials, and chemical substances are stored in the same storage area, which can induce food contamination. As a result, other than time wasting and energy consuming, this traditional way of processing are also with a low hygienic concerns. The standard of quality and hygiene as well as safety for the production is adopted as well. Thus, the transformations for this traditional processing to automated processing system is crucial for overcome those conditions. Before the transformations, let's perform the quality function deployment first. For your information, quality functions deployment, QFD is a set of tools used to define customer requirements and convert them into detailed engineering specifications. Basically, it has four sets, and House of Quality HQ is the first phase. Is the house of quality of the fully automated system productions of Keropok Lekor. Firstly, the WAS, which is the customer requirements of the automated system production of the Keropok Lekor. Each of the customer requirements is with a relative importance from a scale of 1 to 5. Here we can notice that the high productions, high quality product produced, and programmer automation score the scales of 5, which means that the customers consider these three requirements have the most important role for developing of fully automation system of Keropok Lekor productions. Next, the house. The list here is the technical design features for the automated system productions based on the customer demand. The roof above it shows the interrelationship among each of the technical requirements, and the rating is based on the roof breaking distance. For instance, the plus symbol, which means strong positively as for the interrelations of dimensions and weight of machines are strongly related to each other. This is because the larger the dimensions of the machines, the heavier the weight of machines will be. The following step is the body, which are ranked according to their correlations of fulfilling each of the listed VOC with the technical requirements based on the body ranking systems. For example, there is no correlation between the operation speed of machines and the ease of transporting the machine, so it is rated as 0. Then the competitive comparisons that visualize the comparison of the competitors' product in regards to fulfilling the VOC listed. And finally, the importance ranking and related importance ranking. The result shows that the highest relative importance ranking is 25.88% by the technical requirements of process control, then industrial and robotic systems, operations, and so on. This indicates that these three specific technical response factors are among that need to be improved first in the automated system productions of Keropok Lekor. So following here are some of the suggested automated machines for the Keropok Lekor processing. First, the height cutting and guarding machines. It has a guiding and positions device that allows the operator to position the fish precisely for the head cutting process. The fish are then removed the guard by a vacuum cutting system automatically. There is an emergency stop device that stops the device once the tank is full of the guard, and the machine will stop and empty the accumulated guard automatically to a hatch and a drain valve before a new circle is started. The net or machine is the universal multifunctional motion machine. It has a water filtration functions to separate the floating objects automatically. Also, the device has a automatic timing cleaning functions that it will automatically lift the liner to separate the fishes from the cleaning water surface after finished cleaning time. For the spraying, it also adapted a timing functions where the different cleaning time and tap water spraying time can be set according to the requirement. Next, the suggested machine is double acting, double speed door mixer. There is a double motion functions here, where both mixer and ball revolve simultaneously during working to increase the mixing effect. Other than that, operator can set the desired mixing time with the accurate programmable timer on the mechanical panel. The opening at the front guard allows the flour and other ingredients to be added at the mid of mixer as well. For the kneading and shaping process of Lekor, foot dough extruder is suggested to use slide instead of manually rolling. This device combines kneading and shaping process together, which improves the work efficiency, which is two-in-one process. Dough will be further kneaded into a smooth textures along the spool sections automatically. The Keropok Lekor come out in constant length and sold to the whip. Then is the air cooling machine. It is suggested to apply regular and cooling the Keropok in front of the stand fan. The top cover can be lifted by an electric motor for easily cleaning in this device. This device is employed Siemens electronic components which ensure the stable performance and safety of the processing. The desired speed of conveyor and fans can be adjusted according to the conditions. The traditional oil coating that carry out with manual operations can be turned into these automatic coating machines with conveyor system that automatically convey the coated Keropok for coating and then packing. It requires minimum amount of oil only to coat the Keropok evenly to prevent them from sticking together. The drained oil can be recycled and used again to avoid wastage and hence help to reduce the production cost as well by using this machine. Lastly, the vacuum thermoforming packing machines is suggested to be replaced the manual packaging process. The machine is carried out automatically to fill, thermoform pack and seal the Keropok. After sealing, the packed Keropok will be labeled by a movable printer, following by cutting sections where the products are cut into separate packages that abundantly increase the output production rate. The diagram on the right-hand side is the improved floor plan of manufacturing of Keropok compared with the previous. This improved floor plan is more systematic, organized, and hygienic. The processes are arranged properly to prevent cross contaminations and smoother the manufacturing flow of Keropok. The production area are designed to divide physically into two sections, which is the first and second sections, well wall to further promote the hygiene of the production area as shown in the diagram. The cooking process serves as the final microbial reduction process, as further contaminations cannot be eliminated in the further operations. Also, there are separate storage areas for each dry materials as well as a cold storage room provided to solve the problems that face in the existing flow plan in the production systems. All of the storages and warehouse is established near the related production area that you can see in the diagram. In order to facilitate the transfer of materials, so for example, the raw material cold storage is located near the entrance of machines and grinding areas to make the transfer of fish and ice easily for the operations. The floor plan of production area is organized in a straight line order, which is the one-way flow from the preparations of raw materials to the packaging of finished products, where the automated machine works together with the manual and mechanized working handling in a wing-like flow. This ensures the process flow from unclean area to clean area to maintain the hygiene of the production area and the fine quality of the finished Lekor. In the production area, the spaces are allocated for each of the machines according to the machine's dimensions, as well as the spaces for the workers to perform their works. This can help to improve and enhance the productivity and efficiency of the productions. For the diagram, the materials can transfer from the air cooling conveyor to the oil coating machines that is managed by the mechanized handling through the built-in conveyor belts so that the materials can be continuously transferred from the cooling to the oil coating process, and this can be more hygienic as compared to the traditional way of processing. In short, with the utilizations of the automated machines, it has totally decreased the labor work and enhanced the efficiency of the manufacturing system. It also results in higher production rate, improved safety of food, decreased fatality time, as well as the labor cost. That's all from me. Thank you.